In this video, we solve problem 6.3.8 from Essentials of Statistics, 6th edition by Mario Triola. The problem statement says, assume a population of 2, 4, and 12. Assume that samples of size n equals 2 are randomly selected with replacement from the population. Listed below are the 9 different samples. Complete parts A through D below. A asks us to find the population standard deviation sigma, and we're asked to round to 3 decimal places as needed. In order to solve this, I'm going to show you my paper. Okay, so this is what we're looking at. We've got a population, and the population consists of 3 values, 2, 4, and 12. And then we're told that samples of size n equals 2 are randomly selected with replacement from the population. So you've got 3 choices. You can either choose 2, 4, or 12 the first time. So that's our first choice. And then you have whatever you choose, you're going to put that back in because that's what it means to sample with replacement. And then you're going to choose again. So if you could choose 2, 4, or 12 the first time, and then the next time you can choose 2, 4, or 12 again, the different samples are found this way. You could have chosen 2 and then 2, or 2 and then 4, or 2 and then 12, or you could have chosen 4 and then 2, or 4 and then 4, or 4 and then 12, or you could have chosen 12 and then 2, and then 12 and then 4, or 12 and then 12. So these are all of the possible ways that you can choose 2 out of 3 of these if you are sampling with replacement, because you've got 3 options for that first position or that first choice, and you've got 3 options for the second choice. You have 9 different possible outcomes. 3 times 3, using that multiplication rule, gives us the 9 outcomes. And these are the actual outcomes that you would get. These are your samples of size n equals 2 selected from that population. Now, the first part asks us to find the value of the population standard deviation. Now, the formula for the population standard deviation is this. You can do this a number of ways. Oops, I guess I wrote variance down. You can do this a number of ways, but one way, I think the most intuitive way, is to take each of the x values and subtract the mean and then square that and then divide by the sample size. That's giving you the sample, or excuse me, I said sample size, I'm sorry. We're talking about population standard deviation. So the population variance is given by this formula. So you take the x values and you subtract the mean of the x values. That's giving you deviation, and then you square them. And then you don't divide by the sample size, you divide by the population size. Sorry, I misspoke. That's population size, not sample size. And then if you want the standard deviation from that, population standard deviation, you take the square root of that result. Now, there is another formula that you can use that's a little bit easier to use, but since n is equal to 3, I think this is pretty easy to use. So let's use this formula this time to calculate that population standard deviation. So we've got 3 values in our population, 2, 4, and 12. And if I want to find the mean, it's easy enough to find the mean. The mean is the sum of those x values divided by that population size. So we're doing 2 plus 4 plus 12. So that's 6 plus 12, which is 18, divided by the population size, which is 6. So that's our mean. And we want to take each of those x values and subtract the mean. That's a deviation from the mean. So we're doing 2 minus 6, which is negative 4. And then 4 minus 6, which is negative 2. And 12 minus 6, which is 6. And then you want to take each of those and you want to square them. Negative 4 times negative 4 is 16. And negative 2 times negative 2 is 4. And 6 squared is 36. So we want to add these up. The sum of these, well, that's 16 plus 4, which is 20, plus 36 is 56. and then we'll divide by the population size 3 and take the square root. So this is 56 divided by 3, and then we take the square root. And now I can get an approximation of that population standard deviation. Oops, I subtracted 3 instead of divided. There we go, square root of the answer. And I get that exact answer, which is approximately 4.320, and so on. And I believe my lab's statistics wanted the answer to 3 decimal places. So let's look at it again. Yes, round to 3 decimal places. So at 4.320. Okay, great. And now it says, find the standard deviation of each of the 9 samples, then summarize the sampling distribution of the standard deviations in the format of a table representing the probability distribution of the distinct standard deviation values. Use ascending order of the probability or of the sample standard deviations. Wow, okay, that's a lot. So let me write that down, and then we will sort of dissect it and remind ourselves what they're asking us to do here. Okay, I'm going to share my paper with you now. All right, now let's read that problem statement again. It says, find the standard deviation of each sample. That's what we're going to do first. Then summarize the sampling distribution of standard deviations in the form of a table representing the probability distribution of the distinct standard deviation values. And then they ask us to use ascending order of the sample standard deviations in our table here. So we just want the smallest sample standard deviation to the largest sample standard deviation. Well, in order to do that, we need to do this first. We need to calculate the standard deviation of each sample. Now we've got a formula for sample standard deviation, and it's actually very similar to this, but it's just a little bit different. Sample standard deviation is given by the square root of the sum of x minus the mean squared divided by the sample size minus 1. So it's not the sample size, it's the sample size minus 1. Notice over here we have the whole population size n. There's no n minus 1, we just divide by n. Here we're taking 1 away from that. We're looking at the sample size and then we're subtracting 1. So n is equal to 2 for all of these because you're selecting 2. You've got 1 item here and 1 item here. So in our case, if n is equal to 2 here, n minus 1 is going to equal 1. In order to use this formula, I need to compute the mean of each of these samples, which is easy enough to do because they're just 2 values. So here I'm doing 2 plus 2, and I'm dividing by 2. That's how we calculate a mean. Add them together and divide by the total number of elements in the set. 2 plus 2 is 4. 4 divided by 2 is 2, which I think we kind of already knew, didn't we? Because if 2 values are exactly the same, their average is that value. So the same is going to be true over here. The average of 4 with 4 is going to be 4. 4 plus 4 divided by 2 is 4. 12 plus 12 divided by 2 is 12. The others are not the same value. So if I'm trying to find the average of 2 and 4, and I know Mr. Triola would not like that I call it the average, I just add them together and I divide by 2. So I have 6 divided by 2, which is 3. Here I've got 12 plus 2 over 2, so that's 14 over 2, which is 7. 4 plus 2 divided by 2, again, is 6 over 2, which is 3. And we're here. Now I've got 4 plus 12 divided by 2, so 16 divided by 2, which is 8. 12 plus 2 divided by 2, that's 14 over 2, which is 7. 12 plus 4 divided by 2, 16 over 2 again, which is 8. So those are sample means, and I want sample standard deviations. So what I need to do is I need to take each x value here, subtract the mean, square those, add them together, and take the square root. Now we would also have to divide by n minus 1, but since n is equal to 2, n minus 1 is equal to 1. So dividing by 1 doesn't really do anything. Now for this first one, both elements are equal to 2. So the sample standard deviation is given by this formula. You take each x value, you subtract the sample mean, you square those and add them and take the square root, and that gives you, well, 0 squared plus 0 squared is of course 0, the square root of 0 is 0. And so you get a standard deviation of 0. Now that is exactly what we would expect, because remember, a standard deviation is a measure of variation in that data set. And if all the values are the same, if they're both equal to 2, there is no variation. So I would expect a sample standard deviation of 0 here, a sample standard deviation of 0 here when they're both 4, and the sample standard deviation of 0 here when they're both 12. And if we use the formulas, you see, of course, you're going to get 0. You're taking those values and you're subtracting the mean. But since they are the same as the mean, you just get 0. So you've got 0 squared plus 0 squared, and you take the square root, which is of course 0, which means that one's going to be 0 too for the same reason. Now these other guys are not as straightforward, but they're pretty straightforward. We're just going to take each x value. We'll subtract the mean. We'll square those, we'll add them and take the square root. And we'll do the same thing here. Didn't leave myself very much space, did I? It's okay. We can make do. Oops, that should be a 4. So I've got a 7 here, and I've got a 3 here and here. Well, this is negative 1 squared, which is 1, and then I've got positive 1 squared. 1 plus 1 is 2, so we've got the square root of 2 there. Here I've got negative 5 squared, so that is 25, and then I've got a positive 5 squared, that's 25. The square root of 50 is the square root of 25 times 2, so that's 5 times the square root of 2. And this is 4 minus 3 squared plus 2 minus 3 squared. We did the same thing up here, but it was just reversed. So I know that's going to be square root of 2. And we've got 0 there. Now I want to do the same thing for this 4 and 12. Those are our x values. And then I've got 12 and 2 as my x values, and 12 and 4 as my x values. And in each case, the mean is 8, 7, and 8. So I'm subtracting 8 here, subtracting 7 here, and I'm subtracting 8 there. Don't forget to take the square root, excuse me. And those are going to give you standard deviations. So that's negative 4 squared is 16, plus positive 4 squared is 16. So I've got 2 times 16 under that radical, so this will be 4 times the square root of 2. And then this is that 5 squared plus negative 5 squared again, so I end up with that 5 root 2 again. And that's the 4 squared plus negative 4 squared, which is still 4 times the square root of 2. So we've got our options here, all of the possible standard deviations that we can get from these samples of size 2 from the population that had 3 values in it. We have sample standard deviation of 0. We've got 3 of those. So the smallest sample standard deviation that we could have is 0. And remember, if you've got 3 possible outcomes or 3 possible values, and you are selecting one of those with replacement, you've got 3 choices for the first one and 3 choices for the second one. So you've got 9 possible outcomes. So there are 9 outcomes here, and in 3 of them, we had a standard deviation of 0. So the probability of getting a 0 for your standard deviation is 3 out of 9, or you can simplify and make that 1/3. Okay, what are the other ones? We took care of this one, and this one. The next one is that square root of 2. We've got 2 of those. So 2 out of 9 of those were square root of 2. And then the next one got 4 times root 2. I had 2 of those as well. And then the last one is 5 times root 2. And we have 2 of those. So we've got 3 out of 9 plus 2 out of 9 plus 2 out of 9 plus 2 out of 9. So that's 9 out of 9. So when we have samples of size 2 that are selected from this population with values 2, 4, and 12, the sample standard deviation is going to be one of these values. It's either going to be 0, square root of 2, 4 root 2, or 5 root 2. And these are the corresponding probabilities for each of these sample standard deviations. Okay, so it asked us to find the sample standard deviation, then summarize the sampling distribution in the form of a table representing the probability distribution of distinct standard deviation values. Okay. Use ascending order with the sample standard deviations. That's what we did. 0, then square root of 2, then 4 square roots of 2, and then 5 square roots of 2. Okay, and I think that's it for that question, or for that part of that question. Let's go to the homework and make sure we answer it. So I've got 0, and then square root of 2 is not on this list, but I bet it's that that 1.14 or 1.414. Just stop sharing for a moment so that we can get decimal approximation. Sorry about that reflection. Square root of 2. And then if I use this SD button, it gives me the decimal approximations. That's 1.414. And I want 4 times that for this guy down here. That's approximately 5.657 when I round to 3 decimal places. And then I want 5 times the square root of 2 for the last one, which is approximately 7.071. Okay, cool. Let's go back over here. So we had that 1.414, and then 5.657 and 7.071. It's exactly what we got. And then the probabilities were 3 out of 9, which reduces to 1/3, 2 out of 9, 2 out of 9, and 2 out of 9. So when we are selecting samples of size 2 from this particular population, there are 4 possible standard deviations, sample standard deviations that could come from that. And these are the probabilities associated with each of these possible sample standard deviations that we found. Okay. Now, part C says, find the mean of the sampling distribution of the sample standard deviations. Okay, so we want the mean of this guy. So we've got all these sample standard deviations, and we're saying, well, what's the expected value of the sample standard deviations? Remember how we do that. If you have values and you have the corresponding probabilities, if you want the mean value of that, given this probability distribution, you take each of those values and you multiply by the corresponding probability. And then you add them together, and that's the mean. So the mean of the sample standard deviations is this. It's the sum of those sample standard deviations times the corresponding probabilities. 0 times anything is 0. And then we're going to have 2 times square root of 2 over 9. And 8 times square root of 2 over 9 here. And then 10 times square root of 2 over 9. And I'm just using those exact values because I want to be more accurate. This plus this plus this. That's going to give me 8 plus 2 is 10. 10 plus 10 is 20. 20 times the square root of 2 over 9. Then we'll divide by 9. And that's approximately 3.143 if I round to 3 decimal places. Okay. Now let's go back to the homework. Okay. And then there's just one last question. And it says, do these sample standard deviations target the value of the population standard deviation? In general, do sample standard deviations make good estimators of population standard deviations? Why or why not? So the mean of the sampling distribution was 3.143, or it turned out to be 20 times the square root of 2 over 9. Now let's compare that to the actual population standard deviation. That was 4.320. This is significantly less than that population standard deviation. So sample standard deviations do not target the population standard deviation. So that is our answer. And then we say, therefore, since they do not target their intended population parameter, these sample standard deviations are what are called biased estimators. And that's it.